Today we're covering 8th grade, Chapter 5, Lesson 3, Pythagorean Theorem. A theorem is a statement or conjecture that has been proven and can be used to prove other statements. You'll use theorems a lot in other math classes, especially when you get to geometry. You need theorems or proven statements so you can prove that parts of triangles or parts of shapes are equal. So first we want to label this right triangle. The side opposite of the right angle is called the hypotenuse. Opposite of the right angle. The two sides that are touching the right angle are called the legs. And the Pythagorean theorem describes the relationship between the lengths of the legs and the hypotenuse for any right triangle. The Pythagorean theorem describes the relationship between the lengths of the legs and the hypotenuse for any right triangle. The theorem states, in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. And you may have even seen this before. A squared plus b squared equals c squared. And they've labeled the triangle over here for you. A and B are the legs, and C is always the hypotenuse, and it's across from that right angle. So let's use this theorem to find some missing sides. In example 1, we're going to write an equation that models and explains the Pythagorean theorem for each diagram. Then determine the missing length. Round to the nearest tenth if necessary. So we start out with our theorem that says a squared plus b squared equals c squared. Then we're going to replace the a and the b with the actual measurements. And it doesn't matter which one's a or b. It just has to be the legs. So I'm going to say the 8 is the a. So 8 squared plus 15 squared is going to equal c squared, which we don't know. Then we're going to evaluate, which means we're going to kind of solve part of it. Like 8 squared is 8 times 8, which is 64, plus 15 squared, which is 15 times 15, which is 225, are both equal to c squared. And then I'm going to put 64 plus 225 together, which is 289, still equal to c squared. Notice my equal signs are somewhat straight. They're in a line, one after the other. And then we want to determine the square root, because see, we want to undo the square, c squared. We want to undo that. So I'm going to find the square root of both sides. If I do it to both sides, it'll stay balanced. Well, the square root of c squared would just be c, because that c squared means c times c. So if I wanted to figure out what's the square root, it would just be one of those c's. Then the square root of 289. That's where we might need to use those calculators. You can put it in the calculator and hit the square root button. It kind of looks like a division sign. And you'll find that it is 17. Let's look at some of the examples you're supposed to work. And notice that we're not always solving for C. We are on this one, but this one they tell you what it is. So let's practice one of those. We start with the theorem, a squared plus b squared equals c squared. Then we plug in what we know. This 8 is one of the legs, so it needs to go with either A or B. And then we don't know B, so I'm going to leave him alone. But C is 10, so that's 10 squared. Then we're going to evaluate, so 8 squared would make 64, plus still the B squared. Then 10 squared makes 100. We want to get the variable all by himself. So right now there's something there beside the variable we need to get rid of. And to get rid of something, we do the opposite. So this is adding 64. We're going to subtract 64. Subtract 64. And if you do it on one side, you've got to do it on the other. In math, we have to keep balance. So if I subtract those, I'd get 0. That makes them kind of cancel. And I'd have b squared all by himself. And then on the other side, I have 100 minus 64. That makes 36. And then I need to find the square root of both sides. And the square root of b squared is just b. And the square root of 36 is 6. So the missing number, or the missing measurement, is 6. Let's try one more of those. Look at next one down there. We have the theorem. And it looks like A is the missing value this time, so 14 must be the B. And c squared is 28 squared. Again, you can use a calculator on your 8th grade material. So first we want to find 14 squared, which is 196. And we still don't know what a squared is, so leave that alone. And 28 times 28 is 784. And then again, we want to get a squared alone, so I need to subtract the 196 from both sides to get him away from that variable. The 196's will cancel, and a squared is by himself. And then 784 minus 196 is 588. The numbers are getting a little more challenging. And we need to get a alone, not a squared, but just a. So we need to do the opposite of squaring, which is square root. So that would be a. And then again, use the calculator. The square root of 588 comes out to a very long decimal. Looks something like that, and it just keeps going. Well, the instructions said to round to the 10th place. And the number in the 10th place is right next to the decimal. So I look next door to that and decide if I'm going to round up or leave it alone. 5 or more, raise the score. 4 or less, let it rest. So we're going to round that to 24.2. So when you put your answers in, make sure that you are rounding to the 10th place. Everything else will get dropped behind the 10th place.